Hi everyone, welcome back to Dragonfly Engineering. So this week we have a follow-up order on an old mold that I made as a prototype for one of my customers, and it's basically like an aggregate filter. So this is the part that we molded in the past. So it's 3 polycarbonate discs, all these little holes in it, and it's a family mold. So 2 discs are identical and 1 disc is smaller and thicker, and these are thinner and larger in diameter. The problem that I had with these parts is that the larger discs would warp. So you can probably see some potato chipping there, and it's because I basically was rushing this prototype and I didn't put enough ejector pins in. So with all these through holes, they all stick into the mold, and the 4 or 5 ejector pins just wasn't enough. So the part would partially stick and then get deformed as the pins pushed it out of the mold. So what I'm going to do here, since we had to make several hundred more of these, is I'm going to fix up this mold that I ran as a prototype and add more ejector pins and also clean up the parting surface of the mold. So here you can see the impression of those 3 discs that were molded onto this machined aluminum. And I've got a little ding here in the mold, probably from prying out a stuck part or something, which actually overlapped into the cavity. Fortunately with this mold, this whole surface is flat, so I'm going to just machine off probably 2 to 3 thousandths, or about 75 microns. And we're also going to add the additional ejector pins to the 2 large disc cavities. Some other things to consider is I attempted to fix the problems with this part by effectively just reducing the molding pressure. But you can see here that I was getting undershots. See if I can kind of playing with the focus here. You can see how we have an underfill here, but the part is still warped. So basically it couldn't be fixed on the molding machine. Let me see if I can get the reflection. Yeah, so you can see basically extra holes here and the perimeter didn't fill out. So the fix to this is more ejector pins. So let's do that. We're going to fix up this mold with ejector pins and load it on the molding machine, and probably train the orange robot to clip off these runners. So these mold cavities were machined using the EDM sinker machine, and this is the electrode that I used. So this is a copper block basically that was bolted onto the EDM machine. And electric sparks, or EDM means electric discharge machining. Basically, this block is electrified, and millions of little tiny electric sparks jump from the copper to the steel, and the machine basically just hops up and down and keeps eating away the steel until this copper shape is embedded into the steel. So some of the issues that we had for the sticking of these 2, and I believe what I did is I probably machined this shape into the copper, burned these 2 cavities in, and then I remachined the same piece of copper, machined off this surface, and then made this electrode, because I can't find a second electrode for these. But it doesn't really matter because the cavities are done. But yeah, so this electrode, when it burns into the steel, you can set the surface finish, and the surface finish is pretty fine, but there's still microscopic little undercuts from the individual sparks blowing little surface holes into the steel. That combined with all these posts, it created like a retention in these 2 cavities. This one actually ejects because this is a thicker part, but these parts, you know, all of the Velcro effect of the EDM finish plus all these drafted posts results in the part sticking. So I was checking out my supply of ejector pins. I have these 1/8 inch ejector pins, and I believe these other ejector pins are 1 size larger. Maybe, I'm not sure what they are. They're not 3/16. Maybe, I don't know what they are. I'd have to measure them to find out. But, so as I showed in the part, you know, the warpage, there's stiction that's occurring here and here. And if I raise up the ejector plate, you can see how basically I don't have enough ejector pin force to keep the part square as it's pushing off and releasing all the stiction forces of these posts. So I think I'm going to take a risk here and just add 2 more 1/8 inch ejector pins. I'm going to add one right here, and then I'm going to add the other one right here. That way we kind of have a ring and then a central post in the middle, because I did see the effect of, like, basically there's an arc this way. This direction because of sticking. So a lot of times you want to add more ejector pins than not, just to be safe, because we're going to go through the trouble of setting everything up, adding ejector pins, loading this mold on the molding machine, drying the plastic, molding parts, and we really want to see that the parts are square. But at the same time, this mold is paid for, so it's really up to me to make the mold work right. So I don't want to expend a bunch of extra cost. So all that being said, I'm going to take the risk and just add 2 more ejector pins to these 2 cavities and do nothing to this one, because this one is ejecting fine. So to do that, I'm going to set this mold up on the Haas mill and find the center. Actually, I'll probably sweep around with the indicator. I'm not sure how I'm going to find the location, but we're going to drill 2 additional holes and ream them for these pins. Oh, I had a spacer in there too. Okay, so we're gonna have to add 4 more ejector pin mounts into this ejector plate as well. Let's see how well this pulls out. Oh, nice and easy. All right, so there is our ejector pin array and all of the holes for our pins. I think this mold was recycled. I see like an old pattern here. Or this mold base. Yeah, it must have been. So, okay, let's load up this thing on the mill and we will drill and ream our additional holes. So I probably have just this loose enough. So I can use the center finder. And there's always debate about how to use these from people on the internet. But I do it the easy way. So I basically get that tip of the center finder into the center ejector hole, and I've got this tool in this ER collet holder loosely, so that if I overdrive the tool down on the hole, it'll just slide up in the ER spring collet. And we're basically nestling the cone into the center ejector hole there. I'm bringing it down and testing. Okay. Now I guess I could check my work with the dial indicator. I'm going to set the 0. I felt a little bit of a lip right there. So I guess this is an opportunity to see how well the feeling of the edge technique for the center finding works. So we'll do part 0 set. I'm going to move the Z up. And then we can slap our indicator on. And we're going to measure how good I found the center, plus how well I drilled a center ejector pin when I originally made this mold plate. Okay, so we'll bring the Z down now. We'll engage the indicator ball there. So you can see the needle's 2.5 minus, or 3, depending on how you look at it. It's more like 2.5. So now I basically found the left and the right position of this circle in the x-axis, updated the indicator to 0, and then spun it around, and it was minus 2.5. So then I moved Y such that the 0 is hit again. And now the needle doesn't move. So that tells us we are centered on this mold cavity. So I was off 2.5 thousandths by using the fingernail, but it could be that this mold cavity was off by 1 thousandth or so as well. So I'd say that wasn't too bad for kind of a quick and dirty. So I'm going to reset the part 0, and now we'll load the, let's see, I think we'll do a center drill and then a drilling operation, and we're going to drill slightly smaller than 1/8 of an inch so that we can follow up with a ream. And I will set up for a drill that will drill through that whole block. Okay, so I'm going to set the height of this tool, this long drill bit, which is 1 size less than 1/8 inch, and I'm just going to visual tool height set this. And then we're going to do a tool change for tool number 5, which is the center drill. And then we can bring that one down and do the same offset or tool height set. So we'll set this tool height too as well. Bring it up and let's program the 4 1/8" holes that we're going to drill into this and ream. Let's fire it up. So we're doing our center drilling first. Well, it sounds like I was skimming the side maybe a little bit. It's not a big deal. All right, now for the drill. I'll slow things down a little bit. So this is a pretty deep drill operation, so it's going to do a whole lot of pecking. And since this is some steel, I forgot what kind of steel, we're going to do the coolant as well, just to clear out the flutes of this drill. And I'm going to babysit it to make sure that the flutes are clearing out, because as you've probably heard me say in the past, you got to peck these drills to constantly clear out the flutes. Once the flute is full of chips, it turns into a solid plug of metal and doesn't work anymore. And hopefully that was just breaking through to this aluminum underneath. Yep, I think we're good. All right, so now we are ready for the reaming, and I'll give it a little oil here. Or it's got some water in it, maybe. Okay, let's fire it up and go. All right, I think we are ready to stick our ejector pins in. Got a slow fall, and this is a vented hole too. So it's just oil friction on the wall of the reamed hole. This one has a little bit of something going on. Maybe I'll give it a chase it again. Give it some oil. Okay. There we go. That cleaned it up. I got the slow oil friction fall in that hole. So I think we're good. We need to drill 4 more holes in our ejector base to house the 4 new ejector pins. And we can use the same mill setup and program that we've been using to drill the holes into the mold block itself. So I will disassemble this ejector plate. Oh, well, I made pockets, so I wonder. I may have to, that would suck. I may have to open up the pocket. Or I'm gonna probably just drill through everything after I pull these pins out, and then I've got pilot holes that I can hog out little pockets for the additional ejector pins. So I'll dump all of these out. It looks like they're all the same height, except for the sprue ejector. I'll pull all these out. And we'll just use one of these as our reference for cutting the new ones. Yeah, and then I'll just reassemble this and find the 0 position and then drill our new holes through. So that's it. Okay, back to the mill. Okay, so I got the ejector plate loaded with the slightly over 1/8 inch drill bit. All right, so let's open up this thing and see if we need to fuss with adding more pocket for our ejector pins. So these are some of the holes we added. Yep. Okay, so I got to plunge down with a 1/4 inch end mill by 1/8 of an inch. So that works out because this pocket is too deep for these smaller feet. Okay, let's go over to the manual mill. Ejector pins to fit in, so that's good. Okay, so we got our ejector pins ground, and now we're going to reassemble our mold. And it looks like I don't think I ever really used guide pins on this ejector plate. I believe I just used all the ejector pins themselves as guide pins. So, but you know, it worked, so I'm not going to fuss over it too much. So we'll put our new ejector pins in, and then start lining them up with our drilled holes. I think I've got some brass bushings here to run some ejector pins. Maybe I actually did use ejector pins, or I took them out for some reason. Yeah, I never actually stuck them in there. But, you know, the mold works, so I'm not going to argue about it. All right, so now we are ready to clean up the parting face of our mold. As I mentioned, there was a little nick right here, and you can also see the imprint from the B side of the mold and even the fish scale that was resulted from the coarse grinding that I did, which was intended to a certain degree to provide some micro venting of these circles, because the only other venting is the ejector pin holes in the mold itself. So yes, it was rough grinding, but that was quasi-intentional. The before or after the fact is up to debate. All right, so let's start our spindle. I've got a shell mill in here with 1/2 inch round carbide inserts, and these are full round inserts. Let me stop it so you can see it, so that we get all the best possible surface finish on our mold, because the tool scallop is resulted from a 1/2 inch radius tool, or 13 millimeter diameter. So that helps with the surface finish. And now I'm going to slowly bring it down outside of the mold cavity area. And I'm just going to look for first contact here. And I'm just looking for the first wisp of a chip to fly off. Coming down at 10 microns per step, or about 1/2 thousandths per step. And we're just waiting to see the first little wisp of aluminum fly away. Or hear the contact. Okay, so we're in contact now. I'm gonna hit the origin so we get our Z height. So now we're gonna move an X and see where we're touching. And we'll just come across. I'm not sure how exactly square I am by remounting this mold block, but I guess we'll find out. And we're gonna come down another 10 microns, or 20, or 30. I'm gonna come back across to see what kind of skim cut we're gonna make. I'm just catching the edge of the corner there. Okay, so let's go down 50 microns. And I'm gonna do a jog and we'll go across. So this is 2/1000 we're cutting off of the surface of the mold. Sometimes I like to spray a little WD-40 to help with the surface finish. And hopefully we're gonna machine off the witness marks from the first molding operation and the little gouge mark, probably from a tool trying to remove a part off of the mold. It's like a asymmetry to the surface. Seems like maybe there's a deformation of the mold from repeated molding. Let me get my cell phone so we can look at that. So I'm looking at the surface of the mold after I did the first skim pass, and you can see the new shiny area where I planed off the mold, and then it kind of tapered out there where that impression of the part is in the original mold surface, and then it came back. So I'm wondering if there's actually deformation in this mold, like it permanently dented it a little bit in the middle. Continue to skim across here. It's kind of hard to say what's going on with this mold surface. You can see the second pass. So that area, that region of kind of that pit in the middle is still there. And you can see how I was cleaning up the edge. And it looks like I had a tool deflection on the original cut. So I'll take another 50 microns or 2/1000 off this entire face, and it should clean up pretty good. And we're taking another 50 microns off. Because I do want a shiny surface on these molded parts on the parting surface side. So now for the moment of truth, we will reinsert our non-specific orientation mold top onto the base. But once we start shooting parts, we'll have to probably remember which side is what. Here we go. So that's our stack up with our additional pins. Again, this is a prototyping mold, so it's not super refined for mass production, but it'll get the job done. It looks like I'm gonna have to call it a wrap for this week. Sorry I couldn't load this mold on the press and start molding some parts. But a friend of mine contacted me just now and said that he's got a 4-foot sheet metal shear, like the stomp shear style, that is free if I can get it out of his garage this weekend. So we're gonna have to switch it up a bit and go and get that shear. It's disassembled, so I need to put all the pieces in the van and then drive it all the way back to here. And then I'll probably have an episode about assembling a sheet metal shear, which would be cool. All right, so I just got back from a night mission where my friend was cleaning out his garage in a hurry. So I got the bits and pieces of a stomp shear. I think it's a 52-inch Inco sheet metal shear, plus a couple other goodies. Original equipment, power supplies in the bag, table thing, a fan of sorts. This yellow thing is an engine hoist, which I use to pick up the bed of the shear and get it into this van, which is basically at capacity. Oh, there's the handle. I put my jack handle underneath the load that I'm picking up. Superior planning and moving. It's gonna want to lay down. Oh, actually I can spin it 90 degrees. Try not to reach under the load too much. Okay, let me rotate this. Yeah, it's probably weighs 700, maybe 600 pounds. So this would be a nice restoration project. Might have to do a little bit of evapor rust on it and reassembly. So this is just a brief sampling of my second round of loot that I got from Roger's garage clean out. This is basically Silicon Valley garage sale situation here. Got a bunch of high-powered power supplies, tons of wire. Got a XY mechanical stage here. You just hook your motors up there. Tons of motors. Whatever this thing is, like a cooling system. More power supplies. This is like a lathe ball cutting attachment. Just a whole gaggle of science. Random high-powered laser. Scales. Old DVDs, 6 feet under, I think, the whole collection. And then countless other geek things buried in all of this. So, anyway, this is what happens when your friend in Silicon Valley calls you to clean out their garage. Later this week, we'll load this mold and mold some of these polycarbonate discs. And I think I'm going to teach the robot how to pull the parts and clip them, the orange robot. And the green robot and its molding machine is going to be running a part similar to these at the same time. So that'll be pretty fun to watch. Anyway, thanks for watching, and a special thanks to my patrons who help support this channel. And if you'd like to contribute to this channel as well, then please go over to patreon.com and look up Dragonfly Engineering. And everyone else, thanks for watching, and I will see you next week. Have a good week. Bye.